Welcome to Summarize Science. Today, we're diving into a fascinating study that asks a critical question. How do colleges decide which math class you belong in? Researchers investigated a university's math placement test, and what they found could change everything for students. Mathematics placement exams are critical gatekeepers in higher education, profoundly influencing a student's academic path. This study applied a multi-method framework to evaluate a 40-item test administered to 198 students over several years. Using traditional analysis, the researchers first looked at the quality of each question. They discovered that while over half the questions were excellent at differentiating between students, a full 30% were considered poor and recommended for replacement. This means nearly a third of the test wasn't contributing much to an accurate placement. However, one question stood out as a superstar, question 6, which involved graph interpretation. It was so effective that it perfectly separated the high and low-performing groups. In fact, this single question accounted for over 20% of the entire test's predictive power, with the top 5 questions making up over half. Next, the team brought in machine learning algorithms to see if AI could predict student placement from their answers. The results were exceptional. An algorithm called Random Forest achieved a staggering 97.5% cross-validation accuracy, demonstrating it could learn the placement rules almost perfectly from the data. But the most groundbreaking part of the study came from an approach called clustering. Instead of using the university's preset score cutoffs, this method let the data speak for itself, finding the natural performance groups among the students. The algorithm found a clear, natural split in the students, identifying 2 distinct groups, a low-performance and a high-performance cluster. The dividing line, or boundary, between these 2 groups was a score of 42.5%. Here's the bombshell. The university's official cutoff for placing students into remedial math was 55%. This suggests that students scoring between 42.5% and 55% were being placed in remedial courses, even though the data showed they clustered with the college-ready students. This is a potential overclassification that could cost students valuable time and money. So, to recap the crucial findings, many test questions were ineffective, a few questions were incredibly powerful, and the university's placement standards didn't align with the natural competency structure found in the data. All 3 different analytical methods pointed to these same conclusions, making the evidence incredibly strong. This has huge implications for the future. The researchers recommend replacing the bad questions and redesigning the system around a more efficient 2-stage assessment. First, a short test to determine if a student is college-ready based on the new 42.5% boundary, followed by a second test only for those who are. This would create a fairer, data-driven system. By combining traditional statistics with modern machine learning, this research provides a powerful blueprint for any institution looking to improve its placement process. It's a fantastic example of how data can be used to build more equitable and effective educational systems. Thanks for watching Summarize Science.